Today in this video we are going to discuss the zeros of polynomials. So that zeros of polynomials, number of zeros of polynomials depends upon only the degree of the polynomial. Suppose if the polynomial it is of the first degree, then it must exist one number of zero of the polynomial. If the polynomial's degree is 2, then it must exist two number of zeros. If the polynomial degree is 3, then it must exist 3 number of zeros. That means the number of zeros of the polynomials depends upon only the degree of the polynomial. You know very well, every first degree polynomial we call it as a linear polynomial. So now let us to discuss and let us to start with how do we find the degree of the zero of the linear polynomial. What is before that you should know what is meant by the zero of the polynomial. Zero of the polynomial, it is nothing but only the value of x which satisfies or which makes the value of the polynomial to 0. For example, okay, now before that I am writing that the definition of zero of the polynomial. What is that? The value of x which makes the value of x which makes the value of polynomial to 0. Okay, now let us to take one example here clearly. So I want to take the first degree polynomial expression. For example, x plus 5. This is a given polynomial. So now I want to know what is its zero of the polynomial. Before that we need to consider what is the degree of this polynomial. This is the first degree expression. That means it must contains only the one number of zero of polynomial. And I'm going to find that zero of the polynomial. So in the trial method we are doing first it now. So now whatever the expression it is given to us, just we need to assume it as p of x first. Here let p of x is equal to x plus 5. Now I'm giving the some values to the x. If I substitute x equal 0 here, the value of the polynomial becomes only the 5. Suppose if I write x equal to 1 there, then substituting in the place of x1 there, then the value of polynomial becomes 6. So as we increase the value of x, automatically the value of the polynomial also increasing. So but I want to make this value to the 0. So for that one, better to you take negative values. So let us to take x equal to minus 3 here. If minus 3, if I write in the place of x minus 3, then it will becomes minus 3 plus 5, which is equal to plus 2. That is not equal to 0 here also. Now go to the next small number, one more small number, p of minus 5. So what is the meaning of p of minus 5? P of minus 5, it is nothing but the value of the polynomial x plus 5 when x equal to minus 5. Now I am substituting in the place of x equal to minus 5. Then what will happen? We'll check it once. So here the minus 5 and the plus 5, that both will containing the opposite signs, and they will get cancelled. Finally their sum will be the 0. So only you can check very clearly in these three, all the values of the polynomial: p of 0, p of 1, p of minus 3, p of minus 5. So where we are getting the value of the polynomial to 0, so in which case when p of minus 5 equal to 0. That means when we substitute the value of x equal to minus 5 only, then the value of the polynomial it is becomes to 0. That means we conclude that if x equal to minus 5, then the value of this polynomial is 0. I am writing that one. Therefore if x equal to x equal to minus 5, then what happens? We will get the value of the polynomial, that is p of minus 5 will be the 0. So that means only it is possible in the case of x equal minus 5, we are making that value of the polynomial to 0. That's why then we can say x equal to minus 5, it is the 0 of the polynomial. Then we conclude that x equal to minus 5 is the 0 of the polynomial. So this is the 0 of polynomial, which one? P of x is equal to x plus 5. So this is in the trial method, but in the trial method we go to find the values of the polynomial with respect to the different values of x. So it is very difficult to you people to find that all the values of the polynomial and observing that where do we get the value of the polynomial to 0. It is very difficult here. That means you should have one more method to find the 0 of the polynomial. Now let us to go to the second method. I am writing here, this is a trial method. The first one, it is the trial method. Now we are going to discuss the another method, how it is means directly we are taking the same example only. This is a method 2. In the method 2, what I am doing, whatever the expression given to us, first we need to assume it as p of x. So I am assuming p of x is equal to x plus 5 here. So then after we need to find here the 0 of the polynomial. I am writing here, look here very carefully. For the linear polynomial, to find its 0, we must equate the value of the polynomial to 0. So why we are equating directly 0 means whenever you want to find the 0 of the polynomial, the value of the polynomial must be the 0 na. So first in this case what we are doing, firstly we are equating the value of the polynomial to 0 such that we will go to find the value of x here. I think definitely you will get x equal minus 5 in this procedure also. Let us to check it now. Now look here carefully. So therefore, if I equate this whole the value of this polynomial to 0 means you will get like this, x plus 5, it must be equal to 0 here. This is the polynomial I am equating to 0. Implies I am going to solve this equation for the value of x, then x equal to, if I send plus 5 to the right hand side, it will become minus 5. So what do you understood from it? Then if x plus 5 equal 0, then we will get x equal minus 5. If I write x equal minus 5 in this case, in the given polynomial, then minus 5 plus 5 will become 0. That means only this value x equal minus 5 will make the value of the polynomial to 0. So whatever the x value obtained, this value, this is called the 0 of the polynomial. Therefore, we can say x equal to minus 5 is the 0 of the polynomial. Is the 0 of the polynomial. Which polynomial? P of x is equal to x plus 5. So this method, it is very important to you people. In the 10th class standard, when they ask to find the 0 of any linear polynomial, we need to write we need to do the problem in the second method only. This is very important, you people. Look at this very carefully. And now let us to take one more example in the another video. We are going to find the 0 of the polynomial, linear polynomial only, by taking the another example. So before that I want to write the 0 of the polynomials directly. We can use them as formulas also. Suppose the polynomial, I am writing here, I am creating the table here. Look here carefully. This is a polynomial. So here in this case we are taking only the linear polynomial. That is the first one, it is ax plus b. and the second one, it is I am writing here 0 of the polynomial. So you can guess what is the 0 of the polynomial. How it will come the 0 of this polynomial ax plus b. It's very easy. Just first we need to equate ax plus b to 0. If ax plus b equal 0, then ax equal to minus b will come. Then x equal to minus b by a. Whatever the value of x, that is the 0 of the polynomial. Suppose if we take the polynomial like this ax minus b, this is a given linear polynomial. We can guess here what is its 0 of the polynomial, that is value of x. If I equate it to 0, then ax plus b equal to 0, then ax equal to minus b will come, and x equal to minus b by a. Okay now, so you can understand very easily. But what I am doing here, so these both are the same only. I want to take here the minus symbol. I want to write the 0 of the polynomial ax minus b. So then it will becomes x equal to plus b by a. It is the 0 of this polynomial. So you can use these both of them as the formulas when the problems we are dealing the objective problems. Now we will go to discuss the next problem, next example, one more example. How do we find 0 of the linear polynomial in the next video. If you like this video, please like it and subscribe it and share it to your friends also. We'll meet in the next video. Bye, all of you.